Let's get started. My name is Dave Bodnar, and this is a seminar, Electronics, Microcontrollers, and Trains. I've been doing similar seminars for about 15 years. And unfortunately, this is going to be the last one here. Don't know what's going to happen next year, but we'll find out. What I'd like to start out with is some objectives, as I've mentioned in the past. By the way, speaking of past, how many have been to a seminar before? Okay, very good. Always like to have some objectives. I'm going to demonstrate various devices and projects that utilize microcontroller operation. I'm big on show and tell and passing things around, so hopefully most of this stuff will get off the table before too long. And what's that? Does that have to go back to the table? If you ever want me to speak again, sure.
Not here.
Explore how easy it is to use microcontrollers and other electronic devices, starting now at 10 a.m. in the seminar room.
Now we're getting more announcements than we want. And there are a lot of things that I'll show you today that do not base themselves on microcontrollers. You can use just with a wire and a battery, perhaps. And here's the most important thing. Hopefully excite you with the possibilities and enable you to begin experimenting and enhancing your railroad. I'd like to start off with the Arduino. How many have heard of an Arduino? How many have used one? How many have been real successful? That's good, a couple of hands, I like that. The Arduino is a microcontroller. There is what's called the Arduino Uno, and I believe in Italian Uno means one. It's the first Arduino that was developed some years ago. It's a family of inexpensive microcontrollers. There are probably 2 or 3 dozen different versions of the Arduino. Speaking of passing things around, here's an Uno. And this is a small one.
The 10 o'clock seminar, Electronic Devices by Dave Bodnar in the seminar room.
Of course. You can pass these around. By the way, you normally don't pass electronic parts like this around because of static discharge and stuff. First of all, it's very humid. Secondly, these are dead. I kill them regularly. How do I do it, or why? How do I kill them? Sometimes by applying too high a voltage to a place that's supposed to get 5 volts gets 12. Bad things happen. I'm reasonably confident, but I still kill them every week or month. Developed in Italy in 2005. Here's an important thing that really makes it attractive. The Arduino is open source, which means they publish all of the stuff. The schematic for all of these boards is in the public domain. If you want to design a similar one, use their ideas, you can do it without any copyright issues. The software is open source. If you like their software, but there's something it doesn't do that you want it to do, you can change it. The good starter version is the Uno that I'm passing around right now. It's inexpensive. How inexpensive? You can get started for 10 bucks. Actually, you can get started for less than that if you shop judiciously. Hardware costs have dropped because everybody and their brother, including the Chinese, are making clones of the Arduino. I think I'm correct in this statement. At least I'd be happy to hear someone challenge me on it. It's become the most popular microcontroller development system in the world. If you just go to Google and type in Arduino, you're going to get back millions and millions of videos and web pages and assistance, things that you can do with it. Why has it become popular? Again, free software to do just about anything you might need with an electronic device is available on the internet. A lot of people think I'm real good at working with Arduinos and programming. I'm real good at internet searching. So if I need something, the first thing I do before I design it myself is see if somebody else has done it. Some years ago, I was working on a project. I wanted a beacon to flash out some things in Morse code. I didn't want to write that. I found it. There was a guy in New Zealand that had written the software. I asked him if I could use it. He said, sure. So I've been using that for the last 10 or 15 years. There are lots of books, tutorials online. How many use YouTube? How many learn from it regularly? I mean, if I've got a bad part in my car, what's the first thing you do? You don't go to a mechanic. You YouTube and see, how do I fix that, and see if it's reasonable. You can experiment without soldering. These things are wonderful, and I'm hoping that at least some of you have experience with them. This is a prototyping board. And this is a piece of wire with relatively stiff pins on each end. And if I need to connect things together, I can just push that wire into one of those holes. All the holes in the rows like this, let me get that up on the screen. All of the holes that go like this group of 5, this group of 5, they're interconnected. And all the holes down here are interconnected, and the ones up here are interconnected. So you can very easily place components, shove an LED into it, shove a resistor, put an Arduino in it, and wire it up without ever touching a soldering iron. That's the big fear a lot of people have. I don't know how to solder, and I want to experiment. I'll pass these around. This is a circuit, and a lot of times when you go to the internet and you search for something about flashing LEDs for an Arduino, they'll show you a picture like this. Is that a schematic? Sure, but is it a scary schematic? I hope not. There's the Arduino, the same Uno we were working with, and it's showing you where to connect which pins. Here's where you're getting power. What are these guys? LEDs, what's that? Resistor. That's the wiring. The Arduino can control just about any electronic device or component. This little bitty device that we have sitting here, I mean, it can control LEDs. We do stuff like that all the time. It could also control a motor on a train if you put the right components in between. Just because it's small doesn't mean it's capable. It can gather and act on things it senses in the environment. An Arduino can sense sound, it can sense light, it can sense motion. Just about anything that happens in the environment, it can sense. Originally designed for use by students and artists. Okay, to get started, you need one of the Arduino boards, and I recommend the Uno because they're inexpensive. As I said, everything is labeled. If you look closely at that board that's going around, you'll see every single pin has a name to it. The software is free, and as near as I can tell, it will be free forever. Most of the boards, at least the ones you work with initially, have a USB connection. This board right here plugs right into USB, right into my computer. I recently purchased some Uno boards for a project for less than $5 each if you go to one of the Chinese websites on eBay. This is great. This is on Amazon. That's what you get in a $35 starter kit. That's an Uno somewhere here. That's a power board that fits into this. That's a remote control. Those are resistors, those jumper wires, a smaller proto board, an LED readout for $35. Comes with a CD. I don't know how good the tutorials are, but it doesn't matter because you'll find other tutorials that people have done on the internet. There is a downside. Anybody know what it is? You have to learn how to program. And you program the Arduino in C, which is a language. I started programming in assembler, which was really hard, but then I started using BASIC, which was pretty easy. I didn't want to switch over to C. It's not a pleasant language for me because of what I've done over the last 30 years. But here's one of the things I hate about C. It's case sensitive. If I name something in the program LED and I make a capital L, capital E, capital D, and later in the program I refer to it to lowercase l, e, d, it won't work. As a matter of fact, if I initially called it capital L, E, D, and I do L, E, D in caps, it won't work. So it becomes a pain. And the error messages aren't always the clearest thing in the world. It's not unusual if I do that misspelling, it'll tell me there's an error in the line before or the line after. And you have to kind of figure out what it's talking about. But fortunately, books and online tutorials are available. Many YouTube, thousands of YouTube videos. There are some resources. These are relative to model railroading. There are people, how many know of Model Railroad Hobbyist online magazine? There's a whole forum, and there's a big section in there that talks about how to use the Arduino with model railroading. Once you see what it can do and how little it can cost, it's well worth learning. I had to change this year. I resisted it for years, but now I'm using them almost exclusively. And I've got access to a lot of different programming languages, a lot of different chips, a lot of different things. This seems to be the winner. Added bonus. You want to get kids interested in railroading? Put some electronics on it. They like that stuff. All right, first program. Let me sit down here. The IDE, the Integrated Development Environment, is a free download, or just search for Download Arduino. It works on a PC, a Mac, or on Linux equally well. Download it, install it, and when you run the program, let me switch over to, let me go to here. Okay. Let me just do a new. Is that reasonably? Yeah, not too bad. Two things you have to do before you get started. You go to Tools, and you tell it what kind of board you're using. That thing up here is an Arduino Nano. How do I know that? Because it's written on it. And you have to tell it what COM port you're working with. When you plug a USB in, it establishes a communication port, so it's COM4, and it's going to be, in most cases, the only one that you have. Here's how easy it is to get started. We've got our little Arduino hooked in. I go to File, Examples, Examples, Basics. Let's get it to blink. It's built in. It comes with the program. There's the program. Let me open that up a little bit. There we go. There are 3 sections that you use in Arduino programs. You might say, boy, there's a whole bunch of stuff up there. All that stuff up there is your own comments. If you'll notice at the very beginning of those comments, there's a slash and a star. You see that right there? What that means is everything you type from there to when you type a star and a slash to stop it is a comment. So these are all comments down to there. And if you only want to comment one line, you put 2 of those little slashes. And it says here, the setup function runs once when you press reset or power up the board. What this does, the setup simply says, take the LED and make it an output. What does that mean? You're going to send information to it rather than gather information from it. And down here, we've got something called loop. Virtually every Arduino program has a loop routine that's done over and over again. What's this going to do? It says digital write, in other words, send a digital signal to, write it, the LED. That'll turn the LED on. Delay 1,000. 1,000 what? Thousandths of a second, a millisecond, so it's 1 full second. Then turn the LED low, which means turn the LED off. Delay again for 1,000 milliseconds or a second, and then continue. If I click on this button right here, it's now compiling the sketch, and you probably see some lights blinking up there. Is it blinking? 1 second on, 1 second off? That's the first thing you do with an Arduino. And most Arduinos have a built-in LED on pin 13, and you'll see actually there's more than one LED blinking there because I'm using 13, plus I've got a brighter one on it. What if we wanted to have it blink faster? What would you change? Let's say the delay to 500 on both of them. And do it. Compiling sketch, uploading, done uploading. Is it blinking faster? What if we change this one to 5? And leave the other one where it was? What's it going to do? Real fast blip in a half second? What if we change both of them to 5? You get the idea. Did I have to know anything about programming? Not really. I'm using somebody else's program and modifying it. And that's how you learn. You take stuff that you know works and you play with it. We getting a good flash out of there? Oh, it's too fast. It's too fast, yeah. Let me change that last 5 to 50. And it's important that you notice that it's too fast because we're going to use that. How about now? Yeah. So it's going on for 5 thousandths of a second, pausing for 50 thousandths of a second, and continuing. Pretty neat. Okay, let's do the next one. And I have a whole bunch that I loaded in earlier. What if we wanted to do a signal crossing? Why am I not seeing what I want to see? Hold on a second. Wait a minute. Sorry about that. Oh, there it is. The only difference on this one, let me use my little laser pointer. I've got 2 LEDs. I've got LED as 13, pin 13, that's one we were using. I added a second one, I call it LED 2, and that's going to be on pin 8. And I've got a counter. We'll probably just take a quick glance at that. And the counter is going to start out being 0. I'm going to initialize everything. This is very cool. You see where it says serial begin 9600? What that says is establish a connection between the Arduino and the computer so that if I want you to, you can report back to me what you're doing. Does that make sense? This Arduino is like a foreign creature. When you tell it to do something, you don't exactly know what's going on inside. But this allows you to tell it, when certain events take place, send me a message. Let me know, give me some feedback. So what we've done here is we've established LED as an output, LED 2 as an output, and we've established the serial at 9600 baud, which is a typical common speed. And serial print, I am at the setup section. So when it gets to that point in the program, you should see on the screen, I am at the setup section. And down here, let's look at the loop. Take that counter variable, which starts out at what, 0? And 2 pluses mean increment it by 1. So it was 0, what would it be the first time it hits that line? 1, second time, 2, third time, 3, and so on. Serial print the counter. So the first time through it's going to be a 1, a 2, a 3, and so on. Turn LED on, it's high. Turn LED 2 low, it's off. And print blink 1, delay for a second. Now, what are we doing here? Taking the LED that was high or on and turning it low or off. Turning the other one on where it was low. Print out blink 2, delay for a second, and continue. Let's see if we can get that to work. Now there's one trick I didn't mention. This is how you get the little box that tells you what's going on. This is the I am at the setup section. 1, 2, 3, 4, 5. Where's 5? 5, 6. That's sending information back to me. Again, I don't expect you to internalize everything I just described, but isn't it cool that you can get that thing to talk back and tell me what it's doing? It's a wonderful tool to debug stuff, because you will have, believe me, you will have mistakes and you will have problems. But if I can put a line in at a certain point where I think it's working up to that point and have it say, I'm at that point in your program and I'm okay. But if you never get to that, you know the program's before, or the issue is before it. It gives you a real wonderful tool. How high will this number go? I think it's 65,500. It's 2 to the 16th, I think, yeah. Big. Okay, let's continue. 2, 4, 8, 16, 36, 41, 22. Yes?
Where do you get the feedback?
Oh, you may have missed that. When you program the Arduino, you get no feedback. Right. See the little magnifying glass? It says, did you see it light up when I hit it? It says serial monitor.
Yeah.
Hit that. And the important thing, remember the 9600 baud I had? You have to have that set to 96 or it won't talk. Yeah, a lot of times people use higher baud rates for whatever reason. I kind of ignore that. Okay, let us continue. Matter of fact, let's go back to the slides and skip over the ones we just did. So we did that. We did that. I'm going to put this presentation, and if my video camera is working properly, the video of what I'm talking about on the internet in the next couple of days. Let me see what else we did. We did that. And all of these notes are going to be on there. So if you want to try to duplicate it, okay, that's where I want to be. All right. Let's load in a program called Fade. This one's very cool. File, open, Fade. Now normally a pin, why doesn't it come up where I want it to come up? It's torturing me. There it is. There we go. Normally when we have a pin connected to an LED or whatever, it's either high, which means on, or it's low, which means off. How do you get it to change brightness? That's what we're going to take a look at right here. We're going to choose a different pin. We're going to choose pin 9. And the reason for that is right here. Let me show you. If you look at the Uno, these are all pins. Here's pin 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Notice that some of them have a little tilde or a little squiggly before them. Those are special pins because they are pins that you're able to have go partially on instead of 100% on. And if you wanted something like ditch lights that pulsed on and off, you would have to use one of those pins. That's why we switched to pin 9. Let me go back to that. So we're setting up with the LED is on pin 9. We're having a brightness level and a fade amount. In other words, how quickly it goes to bright or not bright. Again, the LED is an output. And down here, do you remember on the other one we had digital right high, digital right low? This time it's analog right, the value of brightness. And down here, what we're doing is making the brightness value 1 bigger. So the first time through here, brightness is going to be 0, so the LED is going to be off. The second time through, when brightness is incremented, it'll be higher. So it'll keep going up. Let me run it and see what happens. I need a mirror. I can't see what's going on. Is it doing something? Is it going dim, bright, or bright, dim? Fading. Yeah, there's a little blip in there also. So you can have pins on, off, or anything in between. Now, if you think back to when that LED looked like it wasn't blinking because we had a 5 and a 5 or whatever it was it dimmer? But actually it was. Because if you think about it, part of the time it was on, part of the time it was off, so it was not as bright as being full on. That's what those other analog pins do, is they change gradually. All right, let's go back to the slides. And again, how is it that a pin that is normally either on or off can give a variable output to fade in and out? There's something called PWM, pulse width modulation, that simulates a variable voltage. It pulses on and off. We were working with thousands. Actually, PWM can be tens of thousands times a second, up in the 20, 30,000 cycle per second range. This can be seen on an oscilloscope. An oscilloscope, this display right here, this is 0 volts. This is 5 volts. And this is about 1,000th of a second from here to here. On this display, a pin goes on for a very short time, goes off for a long time, goes on for a short time, and so on. If you do that, the LED is going to be very dim or darn near off, because most of the time it's off, it's on a little bit. What if you do this? Here it's on for about half the time, or excuse me, off for about half the time, on for half. It's going to look as though you're giving it about half the voltage you normally would. It's going to be medium bright, if you will. And finally, it's off for a tiny bit of time, on for a large bit of time, off, and so on. That's going to give you just about the full voltage. I have a demonstration. This is one of my favorite gizmos that I made a couple years ago. Okay. What this is a potentiometer, fancy word for a volume control. It's actually getting loose. Okay. That's an oscilloscope. Matter of fact, it's the same oscilloscope I took pictures of up there. And if you turn the potentiometer, you see the LED getting brighter? You might also notice the motor spinning. Again, you may not be able to see too well from where you are, but I'll pass this around. You see the scope changing? That's how you get variable speed, variable brightness with something that normally turns a pin on or off. And this is exactly how the motors on your trains are run at variable speed. There's a computer inside of that, if you're using DCC, I should say, or radio control, that changes it from mostly off to mostly on. I'll pass this around. I'll turn it down so it doesn't blind you. Okay. Any questions up to that point? All right.
Now, does this have to be powered with smooth current? I mean,
Well, it should be reasonably clean.
yeah, if you say like we're running PWC and you have something on your locomotive, will that pulse width affect the performance of the Arduino?
Shouldn't. You might have to throw a capacitor in there to clean it up a little bit. I mean, the devices require relatively clean power, and that's why a lot of times you'll see big capacitors inside of those locomotives. And a capacitor is kind of a smoothing thing. If it sees big pulses, it'll bring them down. But it should be something that's dealt with. Yeah.
So you wouldn't power the motor from the actual.
Not directly.
No.
You'd run it through a...
You're running an Arduino to say like 2 lights or something.
Oh, inside of an engine.
Inside of an engine.
Off the same power supply as the track.
Yeah, and your track power is PW.
Yeah, you'd need to put a bridge rectifier, which changes the pulsed DCC power into straight DC.
Right.
Yeah. There's a whole article on my webpage that talks about how to get 5 volts out of a train. I give tips every once in a while. This is my #1 favorite tip ever. Did I tell you the story about Santa Claus? The reason I discovered this stuff? We were putting a train layout in the window of a music museum in Franklin, PA. How bad is that? And we had a Santa Claus we wanted to stick on a chimney on a house, and he kept falling off. And my buddy's wife is into crafts. And she opens up her purse. You know, women have stuff in their purse. And she pulled this stuff out. And she said, use this. This is the stuff that's on the back of a credit card when you get it in the mail. Some people refer to them as boogers. It is the most fantastic adhesive in the world because it's semi-permanent, semi-removable, but we stuck it on the bottom of Santa Claus and put him on that chimney. He was there for a month. I use it all the time instead of hot melt glue. Hot melt glue, you got to heat up the hot melt gizmo and you're going to burn yourself and it takes a while to cool. This is immediate. One of my favorite things to use it for, if you're putting a diesel engine back together and there's like 500 wires coming out the sides and you can't get the body back on the engine, take a couple of these things, stick them on the side, push the wires into it, and they're stuck. I'll pass this around. You get this stuff at Michael's. Let me skip past this. I like this particular one that are actually dots. The ones I had recommended prior to this were like 1 inch long and 3/16 wide. These dots are wonderful. Anyway, I'll pass these around. Go to Michael's and go online. There's like a 40% off coupon, so you can get them for like $2. They're absolutely wonderful. Another one that's really neat. I got to show you this. Let me skip something for a minute and just show you the picture. Yeah, this is one of my favorite gizmos that I can't find. This is about, whoa. Why did you do that? This is about $30. And I don't know how they do it, but somebody really smart developed this. If you turn it on and put a component into this little clamp down here, this is what's called a zero insertion force socket. And it's got pins on it numbered 1, 2, 3. There's a bunch of duplicates of 1, 2, and 3, but they're basically 1, 2, and 3. If you take, and I put a transistor into it, it knows it's a transistor. I didn't tell it it's a transistor. And it knows which lead is the emitter, which is the collector, and which is the base, and what the characteristics of the transistor are. It's magic. But the thing that's unreal is you can stick an LED in there, and it'll figure out that it's an LED, what the forward voltage is, and what the polarity is. If you have a resistor and you don't want to get your ohm meter out, shove a resistor in there, push the button, it'll tell you what the resistance is. Capacitor, an inductor. Magic. I'll leave the transistor in there. By the way, it's stuck to the frame with one of those boogers so it doesn't fall out. But just push the button, let it cook, and it'll tell you what the characteristics of that transistor are. Wonderful toys. You can get that on Amazon.
What is it called?
I call it an electronic component tester.
Will it tell you if it's bad?
Well, it'll tell you the characteristics, and if you put a transistor in and it comes back and says, I don't have anything, it's bad. And if you're expecting that it's an NPN and it's a PNP and it says the other one, you'll know it's bad. So if it's an LED, it will not. Yeah. The thing that's cool when you stick an LED in it, it'll pause for a minute and you see the LED blink a little bit, and then it'll say, you're an LED. How do it know that? I don't know. Anyway, that's my favorite thing. I really like that. Oh, it also does infrared remote testing. That's what that is. Take your TV remote and point it at it. It'll decode the signals. And it's rechargeable. 30 bucks. Okay. All right, let's go back to our ditch lights. Which one do I want? I want to go to, hold on a second, excuse me. Let me go by that. There's what we want to do now. Okay. Okay, what we're going to do on this one, let me program it first and then we'll go back and talk about it because it's pretty cool. Okay, is it pulsing one to the other? I've got 2 of those analog pins. Remember the ones with the little squiggly line before them? And if you look down here, it's the same program we did when we had it going a minute ago. The difference, you may recall I told you that the Arduino could talk to devices like motors, lights, so on. It can also sense the environment. This is a very cool thing. This program, look what I can do. See what's happening? It's pulsing faster, slower, 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 slower. That's a potentiometer, sometimes called a pot. It's like a volume control. And what we're doing up here, I've got 2 LEDs that are outputs. Down here, let me find it. Oh, here it is, the sensor pin. I tap into pin A0. You may have noticed on the Arduino when you pass it around, some of the pins were marked with an A, A0, A1, A2, A3. Those are pins that have an analog input capability, analog being they can vary from one voltage to another. And what this does is it reads the pot. Why am I not seeing? I think it's below the line. There it is. See where it says sensor value equals analog read of sensor pin? What it's doing is it's going out to that pin and it's reading what it's set to when you're turning it, and that's what's determining the delay between one fading and one getting brighter. Now let me go back to here and show you how it works. This is what we do to pin 0. This wire here goes to pin 0. What is this thing? It's a resistor. And typically this is a 10,000 ohm resistor, a 5,000 ohm resistor, something fairly high. But the neat part is you take that resistor, you connect one end of it to 5 volts, one end of it to ground, 0 volts, and you have what's called a wiper. This arrow is representative of a wiper that goes up and down, If the wiper is up here, how many volts are we going to see? And if the wiper is down here, you're going to see. And if you put it about there, it's going to be, you know, roughly a little above half. The Arduino can read that. And at one end, it's a 0. At the other end, it's 1023. Why is it 1023 instead of 1000 or 999? It's binary. 1023 is 10 to the, or 2 to the 10th, which is an even number to a computer. One of the things you have to get used to when you're working with these devices, they start counting with what number? 0. And they don't go up in tens, or they go up by base 2. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. You know, that's binary. Get used to it. That's the way they work. Okay. Let's do one more thing with this. So far, we've been able to send to an LED, turning it on, turning it off, turning it someplace between on and off. We've read the position of a potentiometer. Now what we're going to do is read a push button. And that's pretty easy. Let me bring in the program. Let's see if that's it. Nope, that's not it. Let's do this one. What's happening on the display? Nothing. There's a little button right about here. When I press the button, watch what happens. Is it blinking? Look what's happening up here. What did it say? Got button push. And in a minute, that's going to go away. There, it's gone. And what's it displaying on the screen? A bunch of ones. To a computer, is 1 on or is 1 off? It's on. It's showing, it's saying I'm seeing 5 volts. And when I push the button, I turn off that 5 volts and it goes 0. And if I hit it, got button push, and you see there's a little 0 there. That's when it actually saw the button push. Could I use this on a railroad with a reed switch and a magnet and start a crossing? What determines how many times it's going to blink? The program. If I wanted to blink more each time, I could make it more. Could I put a second switch further down the track and it'll blink until it hits the second switch? I mean, all these are relatively easy to apply to a model railroad environment. The other really cool thing, that looks very complicated. You can have it. Just, you know, if you can't get it off of the slides, call me and I'll send it to you. I mean, it's no big deal. And then if you want to change it, go right ahead. By the way, it blinks 10 times, and there's the 10. Change that to a 20, it's a 20. Okay. Questions up to there?
You change that to a time.
Yes. One of the really cool, I'll digress. The really cool things that convinced me I wanted to use the Arduino, it has built into it a background timer, which means it has a clock that as soon as you turn it on, it starts counting seconds. And I think it's good for about a month till it resets to 0. And you can call on that number. So you could say in your program, when I start blinking, record what the time is now. Keep blinking until the time is 60 seconds more than it was when I first did it. And it's, I mean, it's not like Swiss watch accurate, but it's pretty darn good. But it's built in. And I used to have to deal with that on the other processors I worked with, and they didn't have it, and it was a nightmare. Okay, let's talk about a lighthouse for a minute. Have you been staring at my little lighthouse? I hope it hasn't bothered anybody. Does that look a little bit like a lighthouse? I like to think it does. Why is it dim all the time? Why doesn't it go off? Because somebody, I used to sell these things, I still do, but not too many anymore. And somebody wrote in and said, a lighthouse never goes off. A real lighthouse, you can always see a glow in the, whatever that thing's called, from light bouncing around. They said, why don't you make it that way? And I said, okay, I actually put a jumper on there. If I pull this jumper off, the next time it goes through, it should go off. So it gives you a choice. But anyway, that's my lighthouse circuit. And that's basically the same thing we showed when we did the fade. But what I'd like to do is take you through a project here for a second. I want to gradually brighten a bulb or an LED to near full brightness, momentarily flash it to full brightness, because that's what a lighthouse does. It goes around, and at one point, it's aimed right at you, and you see a flash, and then it goes away. Delay for a set time, and there is a potentiometer on there that lets you change the time. Repeat. Now, one other thing that I have not talked about, that's a pretty bright LED. The Arduino is not talking to that LED directly. It can't. It can only handle about 50 milliamps, which is equivalent of maybe 3 small LEDs. This one is drawing close to a watt, a whole bunch of milliamps. You can see right next to this is a device, that's a transistor. The Arduino is talking to the transistor is talking to the LED. The transistor has the ability to control huge lights. So that's how I'm getting away with having a fairly bright light off of a pin on an Arduino. I used to bring a transistor that was this big, like that big by that thick, off of a trolley. The electronic control. You could have an Arduino hooked to that transistor that would run the motor on a trolley, a real trolley. So yeah, it'll do it. Okay, and again, it's not just on and off. Let's skip that. Okay, when I decided to make this, when I was planning for this presentation, I said it'd be kind of neat to take people through what I used to design not just the circuit, but I don't know if you can see from where you are, but that's a pretty nice looking green circuit board that it's sitting on. I designed all of this stuff and had the board made in China and sent to me for what I think will surprise you in terms of cost. There's a program on the internet called EasyEDA, and it will allow you to design a schematic, a circuit, for anything. And once you've designed that circuit, you can transfer it into a printed circuit board design program. It will help you to design that printed circuit board, and then you'll send that circuit board off to a fabrication plant in China. They will fabricate it, turn it around in a couple of days, and send it to you. Yeah, it's pretty cool. Let's start off. There's my schematic. Does that look familiar? That's one of the Arduinos. This, remember I said there was a big transistor that talked to the LED? That's the transistor. That's the big LED. You remember the jumper I had that would allow it to dim or not dim in between? That's this guy here. This is just a power supply. This is just the stuff that gives it clean voltage. But that's the schematic. That's all the wires that you need. It is not particularly difficult to use. Are there video tutorials? You bet. Tons of them. I learned it in not even a day. It was very nice to work with.
It comes with no components on it. You have to...
If you look over here, there they are. And that list goes down quite a ways, plus there's another library. So I went into the library and I picked an Arduino Nano, and it gave me that.
So it comes on the board.
It comes with the software.
So you're saying what? You just get the board itself with...
Oh yes, yeah, I have to put the components on. They will put the components on and solder them and send you a completed circuit. That's a lot more money. And I've never done it. But if I needed 100 of them, you know, I would probably get one board, solder it myself, make sure it worked, and then say, yeah, go ahead. But yeah, I wish they had this 10, 15 years ago when I was commercially selling stuff, but I'm not going to do it now. Anyway, you get the schematic of parts and connections, then you transfer that. This, boy, that doesn't show up real well, I'm afraid, with the black. This is the actual printed circuit board. And these are the actual wire lines that go from part to part. This is where the power goes in and so on. But the very cool thing, you can preview what the board is going to look like right on the program. That is what the board that they deliver to you will look like. And again, it doesn't show extremely well, but those are the wires, the actual traces. Let me pass a couple of these around. You give it the physical dimensions of the board. It's up. The deal that they have, I'll get to in a minute, is a 10 by 10. centimeter, which is like 4 inches square.
Welcome to the East Coast Large Scale Trade Show. We are ready for our first door prize drawing. The number
I'll pass these around.
is 558735.
If this wire comes off, the power wire,
Drawing is 5.
if you don't know what you're doing, don't put it on, because if you put it on backwards, it'll blow it out. And there's the circuit board.
If your number is 558735, please come to the office and claim your prize.
And look at that. In the program, you can spin it around and look at it 3D. So you can check the back. Very cool. Okay.
Soldered a header on it, that way you can just plug your components right in.
You could, I suppose. I do my own soldering, but yes, yeah. Once designed, there's a company called JLC PCB. Their boxes are here. This is amazing to me, and I want somebody who's got a degree in economics to explain it. They have a service that will get you 10 circuit boards, not 1 or 2, 10. $2. Explain that to me. And this has been going on for about 3 or 4 months, so if it's a promotion, it's a heck of a promotion. Now, I will be quite honest with you, it's $2 plus $7 shipping.
It's only $1.
It's less than $1 a board. And you'll get that in about 3 weeks. I was in a hurry for some boards that I was using for the the incline. I designed them whatever last Monday was, not 3 or 4 days ago, but a week before that. I designed it Monday morning, shipped it off to Monday afternoon, and I had them the following Monday. I'd have had them a day earlier, but DHL doesn't deliver on Sunday. So I would have had them in 6 days. And I paid $16.67 for shipping. But if you're in a hurry, it's still $2 a board.
It's like you're buying the shipping and the boards are free.
Yeah, but they're paying DHL that's all air. I mean, I was following it. Goes to here, bonds up in Cincinnati and trucks to Pittsburgh, and So if you have anything that would benefit from having a circuit board, even if it's an array of LEDs, you want to do something wiring for a switch or whatever. And can you put multiple things on one board and cut them up with a saw? Sure. I mean, they don't care. This is my first invoice, $8.62, and that was for the Lighthouse. And it was $2 for the merchandise and $6.62 shipping. Here's my second invoice. This one took 3 weeks. The one that was $8.62. This one took a week, $18.67. Software's free, not that hard to use. The tutorials are great, and the price, you can't beat it.
Made in America.
Yes. Probably Shenzhen. Yeah. Shenzhen, a city that didn't exist 25 years ago. Yeah. Okay. The what? They're not that bad. When I was in Shanghai, the nice part of Shanghai was nice. The old town was not so nice, a little scary. Okay, the boards are, as you see, as I'm passing them around, they're absolutely beautiful boards. And now what did I have to do? I had to gather together the Arduino, that's a voltage regulator, the transistor, the LED, a potentiometer, and solder them together, but that's not a big deal. Not a big deal. And you'll have mistakes the first time you do it, but it's a $10 mistake. It's not that big a deal. You'll learn from it, and you'll be able to take a razor knife if you made a connection you didn't want. You cut through the traces and run a jumper. I mean, I do that all the time. And you might say, well, there's David's software for the Lighthouse. That looks complicated. I wrote it, and you're welcome to use it. So if you want a Lighthouse, as a matter of fact, if you want one of the boards, I can send you the files, and you can go to JLB, have them ship it right to your house, get 10 of them for $8.
You can probably use that for an airport.
Yeah. Yes. Lighthouse Airport does a whole bunch of different things. And that same board will do Morse code. It's just a different piece of software. So, you know, whatever you want to do. Okay, another tip. How many of you are solderers? How many have a good soldering iron? Digital. Good. This is another one of those deals. You can spend a couple $100 on a digital soldering station like that. This one from our friends at Marlin P. Jones in Florida is $48.95 plus, I don't know, $8 shipping or something. I have 2 of them. The reason I have 2 is the first one I bought was absolutely wonderful. Used it for a couple of years, and it died. And I panicked. So I ordered another one. And when it came, I discovered that what was bad was this. That's like $6, $7. So now I have 2 soldering stations and a whole bunch of spare heater arms. Yeah, $6.95 for that. Also, and I'll pass this around. This is a quality piece of equipment. This is the replacement that I had. Pass that around. This is the other very cool thing. If you're using a soldering iron and the iron gets dirty, and they do, they usually give you a little piece of sponge and you dampen it. Well, that cools the iron. I don't like doing it. This is what you want. This is like spun aluminum. And you stick your tip into it and pull it out, and it comes out shiny. And this is, you know, from Marlin P. Jones, I think $6 or $7. I'll pass that around also. It works beautifully. Okay, let us continue. How are we doing on time? Ooh, talking too much. What if you don't want to fool with a microcontroller or an Arduino or something like that? All you want is a lousy LED to flash. Everybody know what a FRET is? Flashing rear end? Okay. You can buy LEDs that have the flashing circuit built into them. So they will go on and off at 1 or 2 times per second. Let me show you. These LEDs are from our friends at Amazon, and they're really expensive. I paid $8.99 for 100 of them. All I did was put it on a watch battery. Now, can you get them in other colors? Yeah, I always buy in white, and I'll explain why in a minute. But you could buy red. And could you connect that up on the back of a boxcar with a watch battery? This will go for a couple days. Not a big deal at all. I'll pass that around. By the way, if you turn the LED over, will it work? Do LEDs care which is plus and which is minus? Yes, they do. The longer lead goes to the plus. Just squeeze it. Why does it include resistors? LEDs are current driven, current sensitive. That's correct. An LED wants a voltage that's equal to something called its forward voltage. And a red LED, that can be as low as 1.5 volts to 2-3 volts. White LEDs, it's typically about 3 volts. If you give it more volts than it wants, it'll eat itself and burn up very quickly. If you put a resistor in series with that LED, the resistor limits the amount of current that goes through. It's kind of like when you squeeze a garden hose, you're like limiting how much water goes through. That's what a resistor does. So they're including 100 LEDs and 100 resistors that will allow you to run it on 6 to 12 volts. The one I'm passing around is running on how many volts? 3. That's a lithium battery. But the very cool thing, okay, all you need is a battery. Again, if you supply, you know, let's say 2 AA batteries, you can run it forever. Don't need resistors. And that's the skirt. Is that a complicated schematic? The little bar is negative and it goes to a battery. I mean, that's all there is to it. Here's the cool thing. If you have to use a battery, here's the resistor in series. That's no big deal. This is the cool thing. Here we go. An interesting discovery is you can add additional non-blinking LEDs in series with the blinker, and all of them will blink. Let me say that again. You got one blinker, and that's why I buy whites. I don't care what color they are, because if I want something else to blink, I just get a blue or a red or whatever LED. Let me show you this one. Down here at the bottom is a single red blinking LED. Those are 4 3mm red blinking LEDs. Now, how many volts am I feeding this? Remember I told you an LED wants its forward voltage? Well, if I got them in series, you add the forward voltages. Since I've got 5 LEDs, I'm running this on 11 volts. Call it 12. And it works beautifully. This was the top of a signal tower that I had made. So I've got a nice array of LEDs around the top of it. And there's the circuit for that. A battery, the blinking LED, and then 3, 4, 5, 10, whatever you want. Could you put some of those LEDs in parallel and keep the voltage down? Yes, you could.
But they won't blink.
Yeah.
They're in parallel even?
Yeah. You'll get into, if they're not identical, you'll get into some weird things.
The blinker has to be in series.
The blinker has to be in series, yes. That's, I'm sorry, I may not have understood your question. You have the blinker.
You have 5 LEDs, if you put them parallel,
Put,
one's going to blink.
yeah, the other ones will be on. But if you put the 4 non-blinkers in parallel and 1 blinker in series with that, they'll all blink, I think. Okay. You can even get, let me show you this. They do not sell see if I can get this right. You see that little guy up there? That's a little bitty surface mount LED. And what's making it blink? There's a red one down below. That's the blinker. So if you wanted something really tiny to blink, you could do that as well. There's a penny. There's the LED. Give you an idea of the size that you can deal with. This was another amazing discovery. A buddy of mine wanted to have a blinking LED that looked like somebody welding underneath a hood of a car. They were trying to fix it. And I said, well, you know, I can do that with an Arduino, but it's a real pain. I said, there are these little votive candles that you can buy for a couple bucks that have a flickering candle effect. I said, take one of those apart and take the circuit out of it and use that. We discovered there aren't circuits inside anymore. You know what's inside? A battery and a flickering LED. So just as they have, let me grab this. Just as they have LEDs that blink, they have LEDs that randomly flicker. And here's a nice example, at least I think it's a nice example. Does that look a little bit like a TV's on inside of the room? Or somebody's welding or whatever, but that's a flickering LED with a bright blue non-flickering LED kind of bouncing through the house. And that's what we used on his car. It looked really cool. And they're real expensive. $9.29 for 100. And again, the other thing that I didn't mention before, these are all the colors and sizes that are available. So you can get 3mm, 5mm, red, green, blue, whatever.
So
That's what
the
Andy
flickering LED and then he had another one too, the other one will flicker too.
The first one I showed you was blinking. On, off, on, off. The one I just showed you is flickering, like a candle flame.
Series, all will flicker?
Yeah, that'll work with that, yes. Yeah. Although I have to admit that I found one, I did order one set of blinking LEDs once that didn't work when I put other LEDs with it, and I don't know why. And I bought some the next time from a different vendor, and they work fine. So one of life's little mysteries. Okay, let's continue with LEDs. That's got more than one LED. I've used displays like that for years. This is a clock that I have sitting in my office that tells me the time. It actually sets itself off of Wi-Fi and does all kind of neat things, but it's using a display. This display is 8 LEDs high and 32 LEDs wide. And you can have it, give numbers, give words, whatever you want to do with it. I decided it'd be pretty cool to put it on a car. And we use this, I belong to the Pittsburgh Garden Railway Society, and inside of this, I'll leave this open. I'm not going to pass it around for obvious reasons. There are 8 of those displays that I used in the clock. And it's hopefully, you still working okay? The very cool thing about that, let me find it. Give me 30 seconds. Guess what I'm going to do? If it worked, it has to finish its little thing. Wait a minute. Try it again. There we go. When we have this at train shows, like the Greenberg shows or whatever, you know, if it's somebody's birthday, we'll put a little kid's birthday up there, happy birthday, Johnny, or Christmas time, we'll have different greetings and stuff. So it works very well. This is all fully documented on my webpage. If you want to build it, let me get it. There's the schematic. It looks complicated, but what it is a whole bunch of series of daisy chain displays. And the 2 cars are tied together. It's doing the exact same thing on the back. Works rather well. Okay, any questions up to there? And again, there's a Bluetooth module that allows you to change the message.
Why can't you guys look
Wait, one person.
the best way to connect the LEDs to the watch batteries?
Oh, what I like to use is, and I'll show you this in just a minute, I do a little trick with bicycle inner tubes. Remind me when I get to that. Yes?
You said you couldn't use it on a moving train. Why can't you use it on a moving train?
No, I do use it on a moving train.
Oh, I thought you said you couldn't.
No, I said I've never used the clock ones on a moving train. But yeah, I thought that was pretty cool. And the thing that's really neat is if you get it going at just the right speed, it looks like the car's moving, but the display's not. Anyway, okay. What does it cost? The displays, I think, are about $5 a piece, and there's 8 of them, so you're up to $40, $50 for that. The Arduino is $3 or $4. The Bluetooth module is about $2. And if you only did it on one side, obviously it'd be half. So it's not. And I'm powering it with a 5-volt, one of these things that you use to charge your cell phone. The little USB substituter. Okay. Another tip. If you're playing around with LEDs and you don't have a variable bench power supply, I've shown those in the past. A bench power supply is one you literally sit on the bench, has knobs, you can change the voltage and so on and so forth. You can get, if I can find it, maybe I can't find it. Well, it's here somewhere. You can get, these little guys from China are about $6. And if you feed it, let me get 11 volts on this one. You may wonder why I'm saying 11 volts. I use cell phone batteries for my batteries, and the cell phone battery is how many volts? 3.7. And if you put 3 of them together, it's 11.1. So anyway, the thing that's cool about this, there's actually a liquid crystal display on there that's showing me the voltage and the amount of current that's being drawn. And there's 2 little buttons. One has an up arrow, and if you see the LED, if I hold the up arrow, it is getting brighter. It's kind of slow. But it's a variable voltage power supply that you can run off of a couple of batteries, or if you have an old laptop power supply, you can put a connector on there and hook it up. I'll pass this around. That one I think is 2 amps. And funny you should ask. This one is 6. Does that say 3 somewhere? Yeah, and there's another one. This one does like 5. So they're marvelous. And this one from Amazon was $14. I actually put them inside of projects because they're cheap enough. It's not a big deal. Okay, the reason I brought that up is because I use them in my smoke gizmo. How many remember my smoke gizmo? It has been updated. Let me show you. It now lives in a little cabin. There he goes. And I'll explain what I did to change it. There's a pump in there that blows the smoke out, and there's a heater that heats the e-cigarette juice stuff that I'll talk about in a minute. And I found that to really get a good supply of smoke, you needed to really heat that heater up to about 5 volts. But if you ran the motor at 5 volts, it was blowing it out like a rocket. So I put 2 of those things that I'm passing around in there. One of them I connected to the heater, and I ran that up to about 5 volts. The other one I connected to the pump, and I ran it down to about 2. So what we're doing is we've got real low pressure on the pump, which allows the smoke to kind of gather. I think that looks great. Okay, let's talk about the smoke. And this was a dumb luck discovery. I thought that I've seen these people with e-cigarettes, and they got clouds. They fill up their whole car. So I bought one. And let me skip over some of this. That's what I initially bought for about 10, 12 bucks. Tore it apart and discovered the only thing I actually needed was this. This is the heater that heats up a little fiber heating element thing and vaporizes the juice. The juice is pure vegetable glycerin. There's no nicotine in it. There's no flavoring in it. There's nothing evil. It's 100%, pure USDA, whatever. I'll pass these around. That's what you need. And it's about, I think you get 5 of these for about 8 bucks. Let me skip ahead. There's the stuff. Pure organic, non-GMO vegetable glycerin. Oh, it's not 100%. I'm sorry. It's 99.9. USP kosher. I mean, come on. That's what's in there. No. Oh, no. They're a whole different theory. The smoke units on a train is usually an oil-based product, which I don't like to run in my house because it puts oil everywhere. This stuff does leave a little bit of a residue, but it's much less offensive. And when I initially did this, this is what I've showed in past years. I'll pass this around. This is one of my prototypes. The heater, you know what that is. That's a pill bottle from CVS. The heater is down here. There's some wires attached to the heater, just 2 wires. You put the juice in here, put the pump, and you could use an aquarium pump. I'll show you the pumps I use in a minute. And that's what's cooking over there. I'll turn it on again because it's fun. And again, this is that voltage device. This is the pump that I use, and I'll get to that in a second. The pump, those of you that stayed at the Wyndham Hotel, was there a Keurig machine in your room? And after you use it, do you hear a pump kick in that kind of purges the lines? That's the pump. You can get them surplus on eBay for 5, 6 bucks. What did I pay here? $2.07. And they work beautifully. I mean, I honestly have never burned one out. And I've run them at train shows for a long time. Okay. My newest design, oh, how did I power it? I used that little power supply. Got that. The latest design, since nobody our age has pill bottles at home, you can build the whole thing with PVC pipe. There's a threaded cap. That goes in there. I just cut a little disc out of plexiglass for the heater, and you drill a hole in there for the smoke to come out. I'll pass that around. All done with PVC. And that's about, I don't know, $1.50 worth of parts at the hardware store. If you have a good hardware store. I'm fortunate. I live about 3 minutes from the best hardware store in the world.
A few years ago, you could use 35mm film canisters, but they're almost extinct.
But, yeah, I still have a couple of them, but nah. Used to be able to get them for free from the photo. Yeah. Okay, let's do thunder and any questions on the smoke? Okay. Thunder and lightning. This was a, I'll call it an animation, although most people think animations have to move. I put this together for Children's Hospital because we have a Harry Potter train layout that was donated to the hospital, and I put this in the castle. with the light flashing at the ceiling. I actually had 4 bulbs, and we had a parent that complained we had to go down to 2. No fun. I'll explain how this works in a minute, but it's a fairly straightforward circuit and not a bad effect. Especially when you have 4 or 5 light bulbs. Okay. Harry Potter, there's the castle. It's beautiful, beautiful. It's remarkable what happens when you throw money at a problem. To make this whole thing operate, you only need, let me show you, that's the whole device. There's an Arduino. There's a little sound card that we'll get to in a minute. There is a transistor that feeds the LED, like 4 or 5 components. Total cost, I don't know, $8, maybe a little bit more. And I did not make a circuit board for this. This is just perf board. You buy this from any number of different vendors, but it's just a board with a whole bunch of holes in it, and you solder it yourself. I'll show you an interesting effect. Back in October, we set up at a local train show right before Halloween. And we took a pumpkin, and we put the thunder and lightning and the smoke in the pumpkin. And let me see if I can switch. I don't know how this is going to show up on the screen. That was a hit of the show. They really liked that. That was pretty cool. And a buddy of mine at the you have to watch this one carefully. Let me start that over again. Why won't you let me start you? Oh, I'll just let it run. I'll start it again. That's a volcano, and you can't see in this image too much of the smoke. Let me start that up again. If you look carefully down here, there's actually lava that'll light up. Yeah, there it is. Coming down, smoke coming out the top. And if you look down here, there's some workers that ran back underneath their shelter, and then when the volcano stops, they run back up to the front. So we have smoke on that one. And finally, this is one of mine. My HO module has a Thomas that carries M&Ms into an M&M mine. And they're blasting inside of the mine. Hear it, siren. Fire in a hole. And there's an explosion synchronized with a real bright light that goes off. Kids like that. They're always worried Thomas is going to get hurt. Okay. Let's talk about the sound for a minute. I have 1 or 2 of these to pass around somewhere. The device that I use for sound, and I hope you think it sounds pretty good. I do, even though I can't find it. That's okay. This little device, that's a penny. That's the sound card I use. It's a little bigger than a penny. If you shop judiciously, you can certainly get them for less than $5. Sometimes you can buy them in quantity for $2 a piece. All you need is this sound card. How many of you have these things at home in old cell phones and you have no use for them? The old micro SD cards? And you can buy them cheap. I mean, anymore you have to buy a huge one, like a 32 gig. But all you need is a tiny one, like a 1 gig or even less. That's what I have right here. This is the sound, or the micro SD. That's where the audio files go. That's all well documented all over the internet. And this is a speaker from an old computer speaker that plugs into that board. So the only things that I have on this board is an old computer speaker. 8 ohms is important, by the way. A lot of them are 4 ohms. Try to get an 8 ohm. It's called a DF player is the name of this device. A button, and I'm using one of those 5-volt cell phone charging gizmos. And if I push the button, not bad quality for a couple bucks. And if you want it louder, you can feed the audio into an amplified set of old computer speakers, and you can blow people out of the room. I'll pass that around. I don't know that you want to listen to it, so I'll just pass it around with the connections. That's, what do I have in that? $3? $4? I'll get to that in a minute. But yeah, the short answer is you put it on that little memory card. You get MP3 files and put them on there. And it's not hard.
And you can choose the sounds?
Oh yeah, you put, I got those sounds off the internet.
I know, you had 3 different sounds. Did you change it, or was it?
Every time I pushed the button, it went to a different sound. And there's a whole bunch of different buttons you can attach to that. If you only ever want to ring a bell, you can attach to a sound number 1 button. It'll only ever play the bell. Did that. There's just a photograph of this thing I'm passing around. Now, if you want to get more sophisticated, let me see if I can find this one. This one I'm kind of pleased with. Let me make sure I get this one right.
Two, 3, 4, 5, 6, 7, 8, 9, 0.
What I did is I put a file on there for about 30 different words. And I had the Arduino pull different words based on what it wanted to report. And what I was trying to do was to build a system for the local high school was putting up a weather balloon with a camera and all this telemetry stuff. I wanted it to be able to transmit in words the altitude and the temperature. And it worked beautifully.
The current altitude is feet. Temperature is degrees Fahrenheit.
So each one of those little snippets, the Arduino would measure the temperature, the Arduino would measure the altitude with a GPS, and then it would assemble the words in the right order, trigger a transmitter on a ham radio band, and you could pick up verbally what was being sent out. Very capable device. Okay. Questions up to there? Okay. Where to get sounds? Here you go. If you Google free steam engine sound or free railroad sounds, you'll get thousands of hits. And once you get those things, you can also search YouTube. You can pull sound off of YouTube. So if you find, like the explosion that I used in the mine explosion, the volcano noises, we find all those on YouTube. There's a program called Audacity, A-U-D-A-C-I-T-Y, which is a free open source sound editor. And if you turn Audacity on, there it is, and you hit the record button and then go to YouTube and play a sound, it'll record it. And then you can come back and you'll see a bunch of junk and the sound you want and a bunch of junk. You can edit it just like you would edit a word processor. Cut that part off, save it. This, I don't know what that sound is. It looks like it might be an explosion or a bell or a train going by or something. But Audacity, if you have any interest or need for dealing with sound files, it's hands down the best way to go because the price is right. And it's very capable. It's been around for at least 15 years, maybe more. And the thunder and lightning that we talked about. We talked about that. Here's how it works. When the Arduino for the thunder and lightning is connected to the sound output of the sound card. On that analog input, remember we had the potentiometer, it could read the values. When the Arduino sees a high volume, it turns the LEDs on. And as soon as the volume drops below a preset number, which is pretty close to that high number, but not there, it shuts it off. And it's perfect, I don't want to say perfectly synchronized, but it's pretty darn good. And it works like a charm. And that's, when it sees a high value, the LED goes on. When it's a low value, it turns it off. The code is, 20, 30 lines, that's it. And it's on my webpage. There's the code. Very simple. Okay, now there was a request. I have all this stuff on YouTube too. Someone wrote on YouTube, well, that's really great if you've got a castle and you want to have thunder and lightning, but in real life, thunder and lightning never come together unless it's in your backyard. You get the lightning, and then X number of seconds later, you get the thunder. And he said, can you do that? And I said, to be honest with you, I don't think the Arduino is capable of doing that, because it's a relatively simple device. I came up with an idea. I was pleased. Did you figure it out? That's not fair. Okay, let me see. Here's what I did. Now, Audacity normally puts out a stereo signal. Both channels are the same, and both of them are mixed together. What I did is I separated the two channels. These are identical. This one is about 4 seconds delayed from this one. I connected this one to the LED for the lightning. I connected this one to the speaker for the sound. Does that make sense? So when you start it, light, 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 thunder, thunder, and light, but they're not synced because they wouldn't be. And if I push a button on here, let me see if this is going to work. Lightning, thunder. Anyhow, I was really pleased with that. That was one of my big aha moments last year.
I was going to suggest that, as long as it's not using the airline, you're going to avoid it, you can superimpose something out of the human hearing range.
Oh, that's a thought, yeah. I thought of all kind of different. This is relatively simple. You just use one channel. Okay. Remember I mentioned the bicycle tubes. I've talked about this before, but I thought it's about time to revisit it. If you're a cyclist, don't throw these away. If you know a cyclist, ask them for them. What is it? It's a bad tube. Makes the best rubber bands in the world. We use these, we cut them with a paper cutter without cutting our fingers off. These are great little rubber bands, and when you're setting up like a train show layout on G-scale, and the rails keep coming apart, you just loop this right at the joints to hold the rails together. Anyhow, I'll pass these around, and there are a whole bunch of different sizes. And you had asked, how do you hold the LED to the battery? Wrap one of those pieces and shove the wires underneath the rubber. Works beautifully. All right, I'll pass these around. You can also use them as clamps, which I get to, I think, in the next slide. There's what I do with a scissors or a paper cutter. And here's a piece, you can't see this real well, but that's a piece of rail, and those are the ties, and there's a rubber band between the ties. Also great for clamps. You can use them to wrap around wood, odd shapes. Okay, I've got about 5-6 minutes. I want to run through the 3D printers and laser cutters. I have 2 3D printers. I turn them on once a year, dust off the cobwebs, and then walk away from them. To me, they're not that great because I'm not that good at designing things in 3D. But you know what I'm going to say. I've got my original. I got that. I'm going to skip over those because my favorite thing in the whole world is a laser cutter. If you don't have one, try to see if you can find access to one. I like the laser cutter. Big reasons. You can set it up in less than a minute. My laser cutter is about 15 feet away from my desk. And if I'm sitting at my desk designing something, I use Corel Draw. I'll say, Alexa, turn on laser cutter. By the time I get to it, it's ready. 3D printer. How many have 3D printers? How long does it take to get ready to print? Couple minutes anyway. And if you have to level your bed and wait for it to heat, then And much faster completion of jobs. I can get a job done, the longest jobs I've done on a laser cutter might be 20 minutes. Longest I've done on a 3D printer is in the days. Well overnight and into the next day and into the next night. Takes forever for a larger design. I am also much better at designing in 2D than 3D. And I can put stuff together to make it 3D from a 2D thing. Okay, there's my first laser cutter, which I bought, I think, 4 years ago. This is an El Cheapo, 400 bucks delivered. It's okay. You'll learn from it, and then you'll sell it and get another one. My second one is a 50 watt. This is a monster. This was 1,500 roughly delivered. Came by freight. You know, the guy had a forklift at the back of his truck, and he brought it into my garage and set it down and left. It was 200 and some odd pounds. But it's an absolutely wonderful machine. It's faster. It burns through more things better. It's got a larger work area. It's about 12 by 18 in inches. It's just a spectacular laser cutter. I love it.
Are there consumables on that laser cutter?
Well, the tube supposedly, but I've had that one going a lot for about 3 years. They tell me that the gas that's in the tube, which is CO2 and some other rare gases, will eventually leak out of the glass, but I've not had a problem. I'm still running good power. I mean, obviously what you're cutting is consumed, but no. And I've had to replace my lenses because they sometimes get fouled and there's some issues with that, but that's after 2 years. So minimal. The big thing about the big one that I got, the new one, it allows cutting and engraving in the same job. Let me explain what that means. This is same as this down here. That's supposed to be a representative of front of a building. Part of that is engraved. Can you see where it's kind of etched? And part of it is cut. On the original laser cutter, I would have to put this into the laser cutter, do the etching, the engraving, and then start another job with different objects to do the cutting, and you had to make sure they stay aligned, and it was a pain. And this one, the new one, I would do all of the etching stuff in green. I would do all the cutting stuff in black, and I would tell it anything you see that's green, etch, anything you see that's in black, cut. And I can change the different levels and things like that. So it allows me to do this whole thing in one job without worrying about indexing anything.
Is the programming difficult?
It's not programming per se. It's all software based. I mean, there's a learning curve, but you know, I didn't find it all that bad. I had it going the first day. Okay.
The software comes with.
Good question. No. Some software does. There's a program called RDWorks, and you could use RDWorks to do everything you wanted to do. I choose to use Corel Draw, which is 150 bucks for the older version that I'm using. A much more capable piece of software. RDWorks, which comes with it, is free, and it's the program that actually talks directly to the laser cutter. So I have a plugin in Corel Draw, so when I design something in Corel Draw, I say, Corel Draw, move the part that I just highlighted to RDWorks. It'll pop up the other program, then I'll actually set the cutting levels and the colors and stuff in the other program. Fair question, though. There was somebody else?
Yeah, does that have to be exhausted?
Yeah, I'll get to that in a minute. Yeah. Okay. 12 by 18. Oh, the bed goes up and down. Those box cars were done on the laser cutter. My first laser cutter, it would have been very difficult to do that because you couldn't adjust the height. But mine will go down about 6 or 8 inches below the cutter. So I could put those in and move the table and get it focused just right. Oh, there's also, at the nozzle where the laser comes out, there is a powered air stream. There's a blower that blows out and clears the debris from the area it's cutting. It also has positive pressure, so no debris or smoke goes up and hits the lens. And that's why I screwed up one of my lenses. I did a couple jobs with the blower turned off because I didn't want it. Yeah, another story. So 20 buck consumable there. Yeah, be prepared. And that's a fairly small one. The bigger ones are like 400 or 500 pounds. They're really, the reason they're heavy is they have to be precise. We're talking about a device that works in the tenths of thousandths of inches of accuracy. And if it twists, it's not going to have that. Okay, caution, the two laser cutters that I bought initially, the little one and the big one, no safety interlocks. What does that mean? David could stick his hand inside while it's cutting. And there is an open area where the unfocused laser beam goes by that you can't see. I put my hand in once by mistake, and I felt warmth and got out in a real big hurry. It would go right through your hand. I mean, yeah. Okay, extreme caution. If you've got kids, I would lock up the power cord or make sure something is done to keep them from turning it on. They do have to be vented to the outside, and they need to be water cooled. Now there are some of them, I have another laser cutter that I'll talk briefly about that has a built-in radiator system that does not need to be water cooled, but it still needs to be vented. They put out some nasty smoke and acrylic fumes and things. Must be grounded. We're talking about something that's running at 2,000 to 2,500 volts. You don't want to short. Okay, we talked about smoke, water cooling. I also put a temperature sensing system into the water cooling bucket so I can keep an eye on the water temperature, particularly in the summer, because the efficiency drops as it gets hotter because the water jacket on the laser tube heats up, and I'll take frozen bottles of Pepsi and throw them in the reservoir to cool it down. What can you cut? Most of the time I'm cutting either wood or acrylic. Paper, cardboard, cloth, leather, most organic materials, including skin. What not to cut? The big one that I've always stayed away from is PVC because it can release chlorine gas, which will turn into hydrochloric acid and do bad things. One of the first things I did, I used to make control panels just with stickers, and then I discovered I could design a control panel, and that's Corel Draw. And that doesn't show real well there. I'll show you that one. That one's done on a piece of plywood. I mean, that's about a 4-minute job. And it's repeatable. I can make 1,000 of those things, and they're all going to be identical. I used to do them with a milling machine. I'd set my mill up and go so far, particularly for these LEDs and the cutouts for the pots. They had to be pretty precise, but it was a pain. Boxes. I do boxes all the time. Let me pass this around. When I discovered that you could do this, what a revelation. That's not glue, there's just little pieces of tape on there. But you can see the joints. The top of this, the face of it is wood, and the rest of it is just clear plexiglass. That's a clock. There's another little box similar to what I'm passing around. Aren't they a pain to lay out? No, because there is a program called BoxMaker. It's boxmaker.connectionlabs.com or something like that. And you literally say, I'm working in inches. I want a box that's 4 by 5 by 6. My material is 0.1875 thick. And that will come up as a PDF. It goes right into Corel Draw. And what I do in Corel Draw is that. There's my clock. Remember, it had year, month, day, hour, minute, second, and those numbers and a hole for the, and the boxes snap together. I'll frequently glue some of the edges, but leave the top loose. Buildings. First building I did was very simple. It's actually this building. This little blinky. And there it is, designed. I actually did it in G scale. How did I get it so little? Well, Corel Draw, you just say reduce it by 72%. Okay, what do you want me to do now? This one, I was kind of pleased with the way it turned out. I painted the back of the plexiglass flat gray, painted the front kind of a brick color, and then when I cut it out, I lightly engraved through the red brick so you can see the gray, and then I cut, obviously, the outer edges and the windows and the door and so on and so forth. And it turned out, and that's same as this little guy. And it has box joints at the corners. Yes?
Is there a company that will do that for you if you don't want to buy it?
Yes. Do I know one by name? No. But if you searched on Google laser cutting service, yes, you'll find it. There's also companies that will do 3D printing for you. Lots of them. Lots of them.
Dave Bodnar, LLC, send you an invoice.
I had a job. I graduated. Okay. Second building, let me show you this one. I was kind of pleased with this. This is a laser cut building that I bought as a kit. And it's, you know, it's HO that big. And I put it on top of a bunch of electronics that run that modular layout I was showing. I wanted it to be clear so that the kids could see all the electronics. I designed it in CorelDRAW, the exact same building, out of clear acrylic. So it's the same building with rafters and everything else on it, and it sits over top of the electronics and you can see through it. I'm going to skip over that. Oh! Nice looking piece of wood. Does anybody remember where this comes from? Does that look more familiar? Think going into your bedroom. This is the skin of a hollow core door. And if you go to one of the architectural recycling places, there's a place called Construction Junction in Pittsburgh, you can buy these hollow core doors for $5 a piece. And take a table saw and cut the outer 4 inches off where they have the solid wood and grab them. Let me show, that's a hollow core door. Grab them and pull, and you get 2 sides. And if you pick a nice finish, don't get painted, whatever you do. But this is really nice wood. And if you ever go to buy this stuff, it can be $5, $6 a square foot, easy. Now, granted, it's painted or it's varnished on one side, but that's not a bad thing for me. Oh, and a little tip: if you go to a place that has a whole bunch of hollow core doors, shake them, and if you can hear the glue rattling around inside, it's all dried out and they'll come apart easier. You don't want to get a brand new one. Don't go to Home Depot and buy one because the wand plywood is terrible. And I'll do the incline, and then I'm going to shut up. I built a G-scale incline 15 or 20 years ago, and I had it out in front of my house at Christmas, and then when the Steelers were in the playoffs in the olden days. And I decided I'd like to do it again, because I built that one just with regular hand tools. This one I conceptualized on Monday, and it was done on Wednesday. And by conceptualize, I mean drawing it in CorelDRAW, in HO scale. I would have brought my G-scale one, but it's like a 16, 18-foot piece of track on the roof of my car. That wouldn't be so much fun. But the cars were designed in CorelDRAW, printed or cut in acrylic, and let me pass those pieces around. That's the car, and that's the base to the car. Those are the pieces to it. And the supports that are holding up the track were done in the laser cutter. There are 2 of them. They're joined together. There's like little finger joints that make that nice and stiff. The building at the top is held on with magnets. I didn't have time to do a full 3D building, so I just did that real quick in Corel. Same with the one at the bottom. Works very nicely. But the thing that's cool, because CorelDRAW is a vector-based program, there's the car in about 1/32, and there's about 1/20. How hard was that? I just typed a couple numbers into the program, said, you know, multiply by this factor, and it did it, and I cut them out. The thing that's very cool, when you look at those things, one of the important details is the yellow trim around the windows. And when I did the first one years ago, I painted all that trim. And it was a nightmare because I had smears and evil things. What I decided to do with this, when I cut it, I had it engrave a little area around each window and then cut out that exact same area out of yellow, like oak tag heavy paper. And that fits right in there. A little bit of white glue. You'd never be able to do that with a brush. So I just spray painted them red, did the detail, and I was done. The hardest part was doing the roof, because the roof was pretty much done by hand. I cut out the cardboard pieces with a laser cutter, but it was a little bit difficult to do that. Okay, 1 or 2 other details. Oh, motors. Have you run across these neat little motors? I'll pass one of these around. I dare you to stop that. What you don't pinch your fingers. That is a gearhead motor, very low speed. It's really geared down. There's one of the motors sitting on a penny. And that's what's been running the incline all morning. They have a whole $3.99. And those of you that are into model airplanes know about these. The rest of you probably don't. Dubro collars. It's a metal donut with a set screw. You buy this metal donut in the right size and it fits right over the shaft of that motor. You tighten it with a set screw, and because it's nice chrome-plated brass, you can solder to it. And that's exactly what I did. Let me show you here. There's a Dubro, the set of Dubro collars. It comes with an Allen wrench and the little set screws. I don't know if you can see, but that's the Dubro the motor, the Dubro collar, and a brass shaft that goes up into the pulley with solder. Don't look at my ugly solder job. Beautiful. And I did another circuit board. We don't need to talk about that. Oh, last thing. And if you need to leave, feel free. How do I know that the incline is at the top? Can you see the laser on my finger? Can you see it on my finger? There's a laser here shooting onto a phototransistor, a light sensor, and whenever the incline breaks it, it tells the controller to reverse. And it's the exact same thing that I have right here. I developed this some years ago. Laser, light sensor. I use this on my module. When little Thomas that was going into the mine, he crosses the main line on the module, and if there's a train on the main line, they wreck. So I have a laser shooting down the module that stops Thomas. And I think I'm about done. Let me make sure I didn't forget anything. Yes?
Is that strong enough to, say, control your lights on a G-scale?
That's flipping a relay. And you can put as big a relay as you want.
What about outside?
Well, you'd have to take steps to make sure that it wasn't going to get destroyed by the weather.
Well, no, but I meant the sunlight. Would that...
You shield the light sensor from the sun. Just put a piece of tubing over it so the laser has to shoot into it and no sun will ever hit it. And you would put it facing north. The light sensor facing north.
Why north?
Because the sun's in the south.
Oh, okay.
Yeah. And this is just the laser and the light sensor going across. There's the motor. Extra credit. What's this? That's my pulley, but what's it covered with? Bicycle inner tube. Because I needed something in there to give some tooth to grab onto the thread. Bicycle inner tube. Okay. And I think we're done. Any questions? TradeElectronics.com. There are cards on the end of the table. If you have any questions, feel free to drop me an email or give me a call. Thank you. And we do not have somebody right after me, so I don't have to rush to tear everything apart for a change.
Good job.
Thank you, sir. Appreciate your stopping.